Hey everyone, welcome to today's session, today's live webcast. My name is Michael Wolf. I'm your host, and I'm really excited to have these two guys with us for this session called Building the Future Kitchen, Rapid Prototyping Your Way to a Next Generation Kitchen Product. I'm excited to have both of these guys, two guys I really respect, both because they've shown that they love food and culinary things, but also that they can really get things together and make things and build things in the kitchen. We have with us Scott Heimendinger, who is also known as the Seattle Food Geek. Many of you may know Scott from that. Also, you may know him from his time with Modernist Cuisine, and before that, Sansaire. I hope I got that right, Scott. I always mispronounce Sansaire.
Yeah, well done.
And I would argue, and I doubt I put it out there. Anyone who could prove me wrong, I don't know if you can. Scott is, I think, the inventor of the consumer sous vide circulator with the seminal piece he wrote back in 2010. That later was reprinted in Maker. His creation there was also cited in, for example, Lisa Fetterman's patents for Namiku's circulator. So a lot of great stuff there. We also have with us Larry Jordan, who many of you know, and if you were at SKS, you probably attended his workshop on building for the future kitchen and maybe saw his connected salumi maker. So these guys are great. We're going to have a great interactive conversation. The conversation today will basically be in three parts. We're going to start with Scott Heimendinger taking us into his workshop and his home workshop and showing off some of the tools and the processes that he uses to build and prototype. And then we'll hand it off to Larry Jordan, who will take us into his workshop and showcase some of the things he uses and some of the processes he uses. So that's really it. And then after that, the final piece, we'll have some questions. I will ask some questions and we'll let you guys ask some questions. So feel free to start thinking about that. As you guys can see in the social sidebar there, the conversation's already starting. Hello from Israel, Sao Paulo, Canada. Scott, you're looking good, according to Gary. So it's a lot of fun. So Scott, we're going to get going. We're going to hand it off to you while Larry and I go kind of small and downsize, and you can take it away.
Sounds good. So first, a little bit of context why we're talking about this now. Obviously, we're living through a really unprecedented time in human history. But if the COVID crisis has made anything at all clear, it's that the problems that face humankind need to be solved at scale. And since the beginning of time, our solution to solving problems at scale is technology. So although we're talking about rapid prototyping for kitchen devices, really, I think the context here is a little bit bigger than that. My goal, maybe perhaps our goals, are to get more people involved and empowered in the idea that you can make something, that you can take a thought that you have or a problem that you've identified in the world, in your city, in your workplace, in your home, and create a solution for that. And I want to show you in 15 minutes, so I'm going to move really fast here, that it is easier and less expensive to get started doing that for real than you might imagine. So diving right in, I'm going to start with an example. So this is, I'm going to share screens here and forgive any screen sharing awkwardness. This is a texture analyzer that I've been building. It's been a little sort of a side project for me. When I worked at Modernist Cuisine, we used texture analyzers to get objective results from experiments. So the way it works is there's a little probe here that goes up and down on a motor and a sensor at the bottom that can sense force. So my wife and I have been baking a lot of bread at home, and we thought, wouldn't it be nice if we had an objective way of measuring our bread baking results? So the 2-second demo is it works like this. I can move the motor up and down, and we can see over here on this graph that we're getting a response of the force. So this is still a work in progress, but I automate this whole thing, and now I've got objective texture data for whatever food I want to analyze. So as an example, how do you get started building something like this? Well, it involves a couple of different components. The first component is a brain. So in this case, an Arduino. If you haven't heard, if you aren't familiar with Arduinos, they're tiny little microcontrollers. So like a computer, but much smaller and much cheaper. But in the last couple of years, they've also gotten extremely powerful. So this guy costs somewhere from $5 to $10. It has a screen, it has Wi-Fi and Bluetooth, it's got onboard storage, and you can plug it into USB and start programming with it, and that's really cool. Arduinos come in all sorts of form factors and sizes. Here's one that I really like called the M5 Stack. It's a little self-contained box like this. It's got a battery pack built in and some pins on the way out. It's got a screen and buttons and a speaker and a micro SD slot. And this is like a $45 or $50 unit. So pretty amazing what you can do for cheap. But then the reason to use something like an Arduino is so that you can interface with hardware. So hardware can be anything. Here is a temperature and humidity sensor, and I bet Larry's going to talk about stuff like this later. Here is a sensor that you can connect to a thermocouple to get really high precision temperature monitoring. This is a set of relays, so if you need to switch on something like a valve or a light bulb that requires a higher load. Anyway, the world is full of this stuff, and it's very easy to find and cheap to get started. But suppose you said, well, I know nothing about Arduinos or programming. Where do I go from here? Well, I want to show you how easy it is to learn. So let's start on a site here called Tinkercad. This is a free to use in-browser site created by Autodesk, and I think it's really cool. And one of the things that they've done in here is created a handful of starter circuits. So I'm going to go to Arduino here and grab their circuit for a button and drag on right there. Now, what's super, super neat is that they've simulated in the browser the interaction between the hardware and the software. So look really closely at this L here where my mouse is. As I click the button, we see that light turn on, right? Okay, cool and also useless for any of our purposes. But let's see how we can expand this. So I want to add a servo to this assembly. So I'm going to drag a servo right on. Now, if you've been on Instagram lately, especially if you follow any DIY maker kind of channels, you might have seen a bunch of people doing automatic soap dispensers where they use a motion sensor and a servo to actuate a soap thing. So I'm going to show you how easy it is with no prior knowledge to build something like that. So what we're going to do is wire this up. We're going to take power to power, ground to ground, and then our signal, I'm going to bring over here to pin number 6. Okay, that's it. Our servo is wired. Now we just need to tell it what to do. So suppose you've never written code before, let alone code for something like an Arduino. Well, Tinkercad has made this crazy easy. I think this is so, so cool. So you can see the logic that's in here. Push the button, and we're going to put the LED pin to high. We're going to add our own logic in here too. We're going to, when you push the button, we're going to take the servo that's on pin 6, and we're going to rotate this to 90 degrees. And when you release the button, we're going to take the servo that's on pin 6, and we're going to set it to 0 degrees. Let's see if this works. We'll start the simulation, we'll push the button, and what do you know? Our servo rotates. Okay. Cool, but also still useless because we're stuck in a simulation, and a rotating servo in a web browser doesn't really help anyone make the world better. But one of the coolest things that they've done here is you can click this download code button, and it will actually give you real Arduino code that you can load and run right on one of your Arduino microprocessor units. So all you have to do is match the same wiring that you've drawn here, and you'll get the same behavior. So without knowing how to write any code, without any tools that you had to pay money for, now you've created something that can interact in the real world. And it's worth pointing out here that it's not just buttons that you can add. You can add all sorts of sensors, light sensors, motion sensors, ultrasonic distance sensors, all this kind of thing. And these sensors are commoditized, they're easy to find, they're very, very inexpensive. Okay, but what I showed on my device here was maybe a little more sophisticated than point-to-point wiring. So if you can see, I've got things wired up on this green board. It's a PCB, or a printed circuit board. Now, why do something like this? Well, when you get to a certain level of complexity, it's really hard to keep track of direct wiring. The wiring can be flaky or can become detached, and then you don't know if the problem that you're having is a software problem or a hardware problem. So at some stage in tinkering, I really like to advance my designs to a PCB or a printed circuit board. It adds a level of professionalism. It makes these things way easier and faster to assemble and a lot more bulletproof. But this looks like some kind of pro thing. How do you get from here, how do you get from tinkering to a circuit board? Well, there's a whole bunch of ways to do that. For my circuit board, the first thing I did was I used this tool called Easy EDA. Again, this is an in-browser tool, and there are dozens of different tools for doing this, where you drag on components from a library, and then you do that same type of wiring connection here. So what we're looking at here in the schematic view is a logical set of these connections. Then from here, you go to a PC board view where you actually lay things out in physical space, including holes that might take a screw so you can assemble things, and where everything is going to go. And then from here, when you're ready, you can generate a 3D view. This shows you exactly what your board is going to look like. But what I just showed might look kind of intimidating. How do you get from 0 to there? Well, Tinkercad has another trick up its sleeve, which is this export button. So you click export and you get a .brd files, a board file, which, as you might have guessed, you can load directly into Easy EDA. Once it's loaded in, you can rearrange your components and hit auto route, and it'll draw all the connections necessary on the circuit board. And there is a circuit board for that thing that we just created in Tinkercad to move our servo around. But now you might be thinking, well, I'm not planning on starting a product business. I don't want to invest a whole lot of money in having a ton of circuit boards printed. I only want to make 1 or 2 of these things. Well, it turns out that we live in the golden era of cheap, easy PCBs. So let's go back to this demo circuit board here that was created. Right from the menu, I'm going to do generate PCB fabrication. So this creates what's called the Gerber file. And here, it's thrown me directly into a checkout shopping cart. So if I want to order 5 of these PCBs, it's $4 total, plus a little bit for shipping, and it'll be here in 3 to 7 days from China. And in fact, that's how I got these PCBs. So super approachable. This doesn't mean that you won't make some mistakes your first time doing this. There's obviously a lot of science. It's a whole engineering discipline is just PCB design. But for basic things like this, yes, you can totally do it yourself. But if you want to control hardware in the real world, well, you sometimes need some physical parts. So in my case, the end of my texture analyzer needs a couple of probe ends here. I don't know how well you can see that, but I'm trying my best. So this is a probe end that screws into the part that goes up and down so that we can plunge this right into the food. And this is a custom part that I needed to design and fabricate. Well, we also happen to live in the golden age of 3D printing, which is super wonderful. So as you can see over here on the left, this is my CAD model for an assembly for a case to go around my controller. Here's a print of my case there that I did in transparent. And similarly, here is a mock-up of one of the probes that I'm using that I printed. Now, the program that I'm showing on the left is Autodesk Inventor, and it is definitely a more advanced program. You can make very complicated, quite real stuff in Inventor and even do simulations on it, how it will respond to stress or heating or all this kind of stuff. But as you might imagine, there is an easy way to get started here. And for that, we're going to go right back to Tinkercad. Tinkercad also includes an in-browser 3D modeling environment. So I won't go through the whole thing here, but it's pretty much as simple as this. You can drag on some basic shapes, change their size. You can add things to punch holes in other things. And it even has a library of circuits. So, for example, a common type of Arduino board you can put on here and start building a case assembly around it. You can also import and export files from other places. So here I've imported one of the probes that I created in Inventor just to show you that I can. But if you're working with other hardware and you have access to a CAD file for that hardware, and by the way, these CAD files are plentiful and circulate around the internet, you can drop that in here and start building around it. Then once you've got a design that you're happy with, you can export it. So you can download a file that represents the 3D model for printing on your own, or you can send directly to a 3D printing service, like one of these, or an online service like Shapeways, for example, that I've used a ton, where you upload your model, you pick the materials that you want to use. So I would say purple plastic or even stainless steel. It gives you a real-time price quote. You add to cart, hit print, and they ship it directly to you. But if you want to get a little more adventurous, you can buy your own 3D printer, and it has never been simpler or cheaper to do that. The one I'm using here, if you can see from my main camera, is called the Elegoo Mars, and right now I think it's about $250 on Amazon. It's a resin-based printer, so you load in this liquid resin that comes in a bunch of different colors and textures and material properties. This is a high temperature one. You can get crystal clear ones, all sorts of things. And then you take that 3D model file that we just generated, you load it into software like this. You arrange the parts on your 3D printing bed, and then you can hit a button like slice. It will depend on the software. And what this does is it takes the model and it converts it into a format that the printer can understand for printing. So here we can slice through it and you can see this sort of CT scan cross-section view. But more importantly, it'll tell me that this print will take about 4.5 hours and will cost me $1.70 in material to print. So this is an amazingly fast way to be able to generate the parts that you need right from your workbench at home and bring your creations to life. So there it is. I'm at 16 minutes, so I went 1 minute over, but that is beginning to end how accessible these tools and techniques are to bring your idea to life. All right.
Hey guys, well, thanks a lot, Scott. I'm going to hand it off to Larry, and Larry, take it from here.
That was excellent, Scott. I think that gets people really acclimated to what it means to have all of these tools and the accessibility of everything. And so I'll kind of build on that and show you the things that I'm doing. I mean, Scott's making some pretty cool little nuanced things there. I'm a little more in the what you call reductive, where I'm using CNC machinery and a few other things to build things and making things a little bit more industrial prototyping. But the kind of thing that I want to empower you and get you excited about is that all of these things that we're talking about are the barrier to being able to do it is very low. Yeah, you got to buy some equipment and you got to kind of be a maker and you got to be interested in it. But it's all within our reach. We can do these things. And so when people come to me and talk to me about this stuff, I generally will always kind of try to have a very positive thing that says, well, is there a problem or something that you're interested in and that you would like to solve? And I work in corporate IoT development with consumer products and manufacturing and smart cities and things like that. So a lot of the things that I do on a daily basis are of a fairly large nature. So occasionally, as I come home and think about it, my passion is cooking, and I was in my first career, I was a chef. And so with all of the things that have happened and the Smart Kitchen Summit and stuff, it's kind of been a real interesting time to get involved in this and to have a DIY approach to this. So very first thing I'm going to show you is I'm going to take you into a project that I've been working on and walk you through all the resources and the way in which I'm doing it. And let's see here if I can. I want to get to an application window. There we go. Okay, so I'm assuming there that, there we go. That's good. You can see that well. Okay. And I assume that that's able to be seen pretty well from your guys' side. So this is a barbecue trailer that's capable of doing kind of massive volume. So it's able to do like 40 briskets. I can do 150 racks of ribs stacked side by side, and so it's something that's fun for me because we do barbecue parties and other things like that, and so we have some catering stuff that we do. But it also represents, if you've ever cooked brisket and done it low and slow kind of Texas style, that's a 19 to 23 hour commitment. And so one of the things that's very interesting about that is that in order for that to work, you've got to maintain your temperatures correctly. You've got to have those temperatures work correctly through the life cycle of the smoke that you're trying to do. And if you were to lose heat or do any of those kind of things, your meat won't really recover correctly from it. So it's a very important thing. There's a reason kind of Texas barbecue is considered to be kind of a bit of an art form. So what I've done here is I've kind of broken down the machine, or the trailer that I have here, into its relative parts. There's a right chamber and a right front and back, and a left front and back, because if you can't see it in this perspective, but on the other side of it, you can lift the doors up. And so there's another heated chamber in there. There's a warming box to the back, and then there's the firebox. And the firebox obviously is operating at very high heat. And you're trying to control all these things over the course of a 22-hour period to make sure that all works out. So my way of dealing with this is that I'm gonna build myself a monitoring solution that allows me to not only keep track of everything that's going on with this thing, but send me text messages when things start to dip down, and then track and capture that data in the cloud, so that each time I do one of these things, I can get to the point where I'm getting better at it and I can see the data. And then at some point I get a robotic arm that throws the wood in there. I'm teasing about that one. So let's talk a little bit about some of the tech that I'm going to show you. So the very first thing that I kind of want you to kind of wrap your head around is that once you start capturing data and trying to analyze it and do something with it, we're all kind of familiar with IoT in the cloud, and Azure you may or may not be, but AWS and Google and Microsoft, there's all different kinds of approaches. This software and this unit has been written on something called LoRa. It's LoRaWAN. And it's a communication protocol that allows you to send data to a single device, but each one of your other nodes can connect to that device without actually having to be configured for Wi-Fi. So this is a very powerful concept, in the concept of saying, I'm going to set up a central aggregator somewhere, and all my devices are going to send data to that aggregator, and all I need to do is just be able to communicate with that aggregator. It's a very kind of low cost and very cool way to do it. And it's huge in smart cities where you might have literally thousands of streetlights that you don't want to have Wi-Fi connectivity to, and you configure it from a central place. So that's the technology that I'm using to connect everything up. I use a company or a site called the Things Network. It's very neat. And you can see that I'm sending application data from my device to my aggregator. Oops, I guess that one failed a little bit. We'll see if we can reload that one. And it captures that data and then forwards that up to yet another application, which is called Microsoft Azure IOT Central. And I'll show you that data. But I do want to kind of like touch on something, as Scott talked about it, is that when you're prototyping and stuff, it's also very important to think through what is the life cycle of building a prototype. And so my prototypes tend to be pretty robust, and I'll show you how I achieve that. And the reason for that is because I want to be focused on the fact that I'm building something and I'm trying to solve a problem. And if I'm breadboarding or doing something or building it and the little electronic parts are falling off and stuff like that, that's a bad thing. But there's kind of a life cycle that you think through when you build a connected device. You need a way to register it. And in these cloud systems, you need to be able to make that device capable of being seen, which is called provisioning. You need to be able to communicate. You need to be able to maintain your software over the life cycle of the device. And you also need to think about ownership. When so you want to sell it to somebody else, how do you do that? How do you handle that? And then you have to think about improvements. How do you do that cycle? So I always try to stress this a little bit with folks as you're thinking about this. You don't have to solve every problem when you're prototyping something, but you need to be cognizant of that. If you really truly want to sell something to the public and bring it out, you got to have that kind of attitude that you're going to have that full life cycle kind of covered. And then here in IoT Central, where I'm actually sending all the data here, let's go in and take a look at this and I'll show you what it's doing. Ignore my login there. And here's my Yoder observer. Okay, and if we go up and take a look at my devices that I have in here, you'll see that I have a device, and I'll show you it's sitting right behind me here on my bench. And if you take a look at it, you'll see that it's sending across data from each one of these areas in the box. So for example, if I change it to, let's take a look at the last day, which represents a full cook, you can kind of see the temperatures being mapped and everything. It's 80, 85 degrees in my office here. So it's not really representative of what you would see inside a barbecue, but it does give you an idea of how you can track over time the differentiations that you're seeing. What was the ambient temperature? What effect did that have? And you start to plot that data and you start to come up with some ideas about how you're going to improve it, or automate it, or those kind of things. The next thing that I like to think about is that when I go to build a project case, in much the same way that Scott was showing really cool 3D printing stuff, I tend to build project cases out of aluminum and seal them up because if I'm making a salumi machine, that's probably in a restaurant type environment and somewhere where there's moisture and things. So I got to think about that. In the case of the monitor for the barbecue thing, that could be outside getting rained on and smoked and all kinds of things that happen to it. So I tend to build them out of aluminum die cast cases that I get from China, and then cut those things and build my cases out of them. I then powder coat those things so that I can actually make them look good and make them look pretty. So powder coating is something that is very accessible in much the same way that printing and CNC machinery is. You buy yourself a little oven, you get a little pancake compressor, you get a little gun, you hook up a negative electrical charge to it, and you bake that thing, and all of a sudden you got this beautiful case that looks really, really nice. And everybody goes, wow, that's great. How did you do that? Well, for less than $250, you can actually make professional cases. The CNC machine that I use is X-Carve, and there's a lot of different ones that you can go out there. I like this one just because as much as I'm excited about being able to do CNC machining, my ambitions around it are pretty low. It's usually 2D. I'm usually cutting project cases. I'm not doing anything crazy. I'm not trying to build parts, space parts or anything like that. So it's a very nice unit and easy to use. And so, for example, the case that I'm going to show you, in much the same way that Scott was showing off some of the software that he was using for doing 3D modeling, this is as simple as it is when you go to build a project case. Draw the pieces on there, test them out on a piece of plastic, make sure everything fits, and then execute this thing on your CNC machine. And it cuts all these things for you, and boom, you're ready to go with your project case. You powder coat it, you put it together. The next piece is that Scott talked about Arduino, and I work with the Raspberry Pi. It's a very popular chip, or system on a chip kind of a board that people use. And I'm a big fan of the Pi because of not only its capability of being able to program it and all the things it does, but because there's such an aftermarket for what are called hats, which are things that you can add on to it to do pretty sophisticated things. So I'll show you that real quick too. And I'm not necessarily going and taking my PCB board and turning it into a product at this point. I'm actually building and stacking on things that are using like relays and stuff like that. So my needs are not as much about being small as they are about being kind of robust and kind of industrialized a little bit. So I'll show you that. And then and when I talk about a hat, so in the case of LoRa, where I was saying that you communicate with it with that network protocol, you just buy the hat, slap it on top of the Raspberry Pi, make sure the thing sits on there nice and snug, and you're up and running, right? So the software becomes really easy. The next thing is that I know that Scott, when he showed the Arduino code being generated from the tinkering tools, I tend to use Python, and Python is a very simple, very accessible language. I'm a huge fan of it, just because it's something that you can get friends and people working in it, and it's a great way to collaborate. So you get on GitHub, you write things together, and it's a really great way to do it. It works really, really well on the Raspberry Pi. So let me go ahead and switch over to the ceiling camera here, and I will stop sharing my screen. Okay, I think we can see that. Good. All right. So I'll come in here a little bit and try and get my head out of there. So in this box here right now, what I have is that it's hooked up with thermocouplers that go into the barbecue, right? And so each one of these is kind of matched with its firebox and everything that it's supposed to go into, which part of the thermocoupler goes into it. And then they all come piped back out and then connect into this box. This box is sending its data over to this aggregator box here that I'm using to actually act as the mechanism for sending the data up to the internet, right, and capturing it. So you can see how these boxes are built. They was done on the CNC machine. They're made kind of pretty. Pink is the color of our little trademark thing there, so that's kind of funny. But the next thing is that if you take a look here, so let's take a look at the kind of componentry, right? So you've got a nice Raspberry Pi attached to a touchscreen, fits right to the back of it, fully integrates, and now you've got a pretty neat way to build an interface for your product, right? The next thing is that you take one of these hats here, and these hats are quite sophisticated. This one here is a digital acquisition hat where you can take in and measure data, and it does things like you can see here how it's flipping through the LEDs as it's going through and reading each one of the box or each one of the thermocouplers. And so that's kind of cool. You plug that in, you're ready to go. This thing does all kinds of data acquisition. In this particular one here, you can see here I've got 7 relays that I can use for being able to switch on and off AC plugs that I use for my salumi machine. So really compact, pretty easy to use. Once you get them mounted correctly, they're robust, right? You can drop the thing on the floor and the thing's going to hold together, right? So that's just one thing that I try to stress with people. So those are some of the approaches that I take for building things and prototyping stuff. My kind of mantra to this is that build your electronics very solid so that when it comes time to actually go do your programming, you don't have additional things that you got to go kind of fight, to try to figure out. So, but this is the way that I kind of do my prototyping, and it's just tremendous amount of fun. So I hope you enjoy that.
Well, thanks. I'm going to bring back Scott as well, and we can have a conversation. Let me turn Scott's mic on. And, okay. Scott, can you hear me? Oh, yep. I think we're back.
All right.
Well, this has been a lot of fun. Seeing and looking in. I was kind of teasing Scott that I was going to try and tease out of you what you're building next for your next product. I don't think you're ready to tell us though. Maybe someone else could be more convincing than I can. And Larry, really cool to see in there. I know she has some guitars there. Maybe we could play us out as we kind of finish up today. I want to start with a question, and then we're going to take it to the audience a little bit. So, guys, start thinking of some questions. I see 1 or 2 questions in the Ask a Question box. Also, if you guys want to ask them on the sidebar, the social sidebar. One of the things I wonder, because I'm not an engineer, I'm not a computer scientist. Do you need a computer science degree? Do you need to go to school and get an engineering degree to build this type of stuff?
So I can start with my experience. Short answer, no. Long answer is that eventually you'll hit limitations as the complexity of what you're doing grows, where some computer science fundamentals really are important. But there is a long way to go before you bump into those limitations, depending on what you're doing. So as you saw through that web interface, I could drag and drop some logic blocks and make a thing that did something that's potentially useful. So you need no education of any particular type to be able to do that. That's even something that a precocious kid could start getting involved in. But one of the downsides of the fact that things like this or the Raspberry Pi are so inexpensive and small and lightweight is that a lot of the things that are done for free in modern computing environments, so writing software for a desktop computer or a cell phone, are things that you need to do at a lower level on these devices. So you don't have infinite memory to store things in. You don't have infinite processing speed. Making things happen concurrently is harder. So short answer, get started. Don't worry about the background, but eventually you'll start to run into constraints.
Yeah, I totally agree with that. I recently spoke at a high school, and one of the conversations for the computer club came up is, I tried to explain to people that I was recycling, replacing in some cases, my skill set every year and a half or so anyway. You think back on the code that I wrote back in the day, C++ and stuff like that, which truly is quite intimidating stuff to do, to the place of writing JavaScript and Node and Python and things today. And I believe that, like what you said, the fundamentals, the underpinnings of how you do that stuff helps you navigate across those various things. But there's just no barrier to entry here to being able to write a chunk of code, do some JavaScript, put something on a chip and make it work. Bad code still runs on IoT. It's okay. And then the next thing is that if you get to the place where you kind of forgot to go to the bathroom for 3 or 4 hours because you were so obsessed with it, now you're on your way. You're in good shape. And so you go and learn about it. And there's absolutely nothing that you cannot go learn on YouTube or in the resources that are out there. I mean, Pluralsight is giving away training right now for 3 months, right? And you can take any class you want. So it's pretty cool.
Both of you gave us a list of links and resources, which I put into a document in Slack. You don't have to go there necessarily if you don't want to. I will also send out an email from Crowdcast with those links. So people who are attending today will get those sent to you. One of the things I wonder, is there like a toolkit you would suggest, if I don't have a lot of money, if I just want to get going, should I go buy a MakerBot 3D printer? Should I start with, is there anything that you feel is essential to have in your toolbox if you're starting to kind of tinker a bit?
Go ahead, Scott.
Sure. Well, I'd start with just some real basics. Make sure you got some small screwdrivers, a decent soldering iron, because you'll want to connect stuff together. If you look on Amazon or some other places like Adafruit or I'm forgetting the name of another site, you can find some kits that give you a board, either a Raspberry Pi or an Arduino, and a bunch of sensors and things to plug together. And it's sort of like the Modern Erector set or the Lego Mindstorms kind of taken to the next level. And that's enough to play and tinker and sort of ignite your curiosity and find out what's missing. I would not recommend, personally, I would not recommend buying a 3D printer before you had designed something and had it printed and mailed to you. The reason is, I don't want to burst anybody's bubble or limit their imagination, but you think, oh, a 3D printer, I can make anything. No, a 3D printer at home, you can make plastic things. And many plastic things are great. You need enclosures or clamps or mounts or other stuff like that, but you'll soon find, oh, well, this part needs to be metal or it needs to be much stronger. And metal 3D printers are not something that people generally have at home. You can graduate to something like Larry showed off, CNC machines and stuff, but by that point, you are really deep in it. Going out and buying a CNC machine would be sort of like the equivalent of saying, hey, I've been interested in driving cars, so I'm going to go buy a fleet of Hummers.
I was hoping you say Porsches, but that's okay.
And you mentioned during your conversation, Shapeways. Tom from Pantry on the sidebar mentioned Shapeways is one of those 3D printing as a service where you upload your file from Tinkercad or a CAD program, and they'll print it to for you and mail it to you.
Yep, couldn't be easier. They'll even show you if your model has any errors in it that cause it to be unprintable. That's a new thing. The idea that models can have errors is not something that you might have anticipated. You'll pay more per part for sure. So my my part that would cost $2 here might cost $40 from Shapeways, but there's no upfront investment. You don't have to worry about cleaning the part. You don't have to worry about getting the print settings right. And it's so cool. It is such a cool feeling that I've designed something on the computer and now I'm holding a physical version of it. If you've never done that before, it will really get you energized about how powerful all this stuff is.
And Tinkercad is free, I believe, right? Or at least very low cost.
Yep.
So that's a great, and you can do it through your browser. We have a question here from Chef Min. Hope I pronounced that right. And I'll throw it out to either one of you guys want to take it. Hello, my company has a cooking hardware product and the device is triggering errors and malfunctions. With the defective units, we still have a hard time isolating the problem and we have multiple hypotheses. How do you recommend we approach the problem?
I'll try that because it's where I live every day. So predictive analysis type stuff or looking at failures is something where your telemetry and your other things that are coming off of your device become extremely important. And so, it feels like it's almost like a question I would ask myself if I was setting myself up to talk about, how do you do maintenance and analysis and predictive failures? And so when you take a look at smart cities and energy and things like that, what are they trying to do? What's the thing that saves them money? Knowing when a street light goes out or a lamp goes out or some monitoring system is going to go out, that telemetry data is what informs you. And so my guess is that when you take a look at this, if you were able to plug in and get your telemetry data, you'd start to be able to see what the pattern is. And again, that pattern means ambient temperature, how many times it came off and on, what were the things that caused before the failures. That is the way in which we do the analysis at kind of a manufacturing, industrial, and consumer level in the areas that I work at in my day job. So those are important things to have. There's really no other good way to do that. It's the way we've been fixing things all our lives. I mean, you've had, how many times has your washer gone out? It was a $5 part. You're like, oh, it just seems terrible that was plastic. Why'd they do that? So that's where the power of being able to do telemetry and capture that data and do those diagnostics, to me, is what's really interesting. And so as I build my devices, not only am I doing kind of telemetry to map out recipes and kind of learn from them, but I've also captured properties and, there's not a lot of parts in there that will break. But you begin to start to get the notion of designing for failure. Right, designing for being informed of failure. Right.
There's a question in the sidebar from and hopefully I don't mispronounce this too bad. Enerud Agrawal, and this is a good point. He basically brings up the idea of food safety, and anytime you're making a food product, you have to think about that. And he asks, for manufacturing and powder coating, how do we get food safety approval to use in a device which is to be sold? Any thoughts on that?
Yeah, so I'll jump in, and Scott, you've actually done this. So I'll tell you what my experience was. So at Smart Kitchen Summit, that was some of the sidebars that I did was with NSF and some of the other folks that represented those kind of regulatory things that actually approve an appliance, because I have an appliance that I want to get approved. And you're right, little things like can the paint be chipped off that and fall into something? And how do you make something safe for anodized coating, compared to a mixer? But you can use a powder-coated mixer from Hobart anywhere, right? They do that stuff all the time. You just have to go through the process of making sure that all of the things are meeting regulatory demands. And so that takes time, that takes money. So I'll hand it to Scott, because you probably went through that with your sous vide.
Yeah. I agree, Larry, with everything you said. The answer here is kind of unsexy, is that you need to find an expert to guide you through this process. Sort of just like you could be your own defense attorney, but it's not always a good idea. You could learn everything needed to pass NSF certification, but it'll be a very expensive use of your time compared to a consultant or expert who knows the things they're going to look for already, who can help guide you through the process. It's worth calling out that everything that we've described today is really all about rapid prototyping. But when you want to make something a commercial product, there are a whole nother set of considerations designing for mass production and consumer safety and all of that kind of stuff that's sort of outside of this scope. And that's where you want to consult folks with expertise.
Yeah, I think, and Scott and Michael, that the Smart Kitchen Summit is actually a place where I got educated on that this year. And there was exactly that. I came away going, okay, I'm going to hire that.
Yeah.
There's no way I'm good enough for that.
Checks in the mail, Larry. Thanks for mentioning that. Keep on thinking of your questions, guys. We have a little more time. You can put it in the sidebar. I want to ask both of you, because I am curious, why did you both hone in on the kitchen? Was food just a natural thing you were interested in? It does seem like that's your specialty in terms of like making and inventing stuff. Why the kitchen?
Go ahead, Scott.
I've always loved STEM, but I've also always loved to eat. And so I found that doing experiments that you get to eat at the end were just more rewarding than the ones you don't. For me, although I've loved to cook and eat and all that kind of stuff, it wasn't until I started to hear about the sort of modernist movement in cooking around the 2010, 2008 in there, when that was taking off as a global phenomenon. And although you might think of that and associate it with like culinary foams and really avant-garde stuff, to me, that was people treating cooking like an engineering discipline. To say there are rules that we're going to understand, document, and share, and if you understand the relationships between things, you can achieve pretty incredible results. And so that was just music to my STEM mind. Is, hey, I love cooking, and I love the structure that comes with science, technology, engineering, and math. So it's natural to combine these things. And the other reason for me is that I'm a terrible freehand anything. I can't draw freehand. You see people who do these gorgeous bread scoring or pastry work or whatever. No. Can't do any of that. But in a structured environment, if I've got Photoshop or CAD software or something else, I can make things that bring my ideas to life in a way that I'm proud of. And so being able to combine, wanting to make something beautiful with building the tools to get there has just resonated with me.
So Pastry Chef was never in the cards for you either.
Honestly, I went to my mother-in-law's house and we were making Heimendinger. This is an annual tradition. If you don't know, Heimendinger is a traditional Jewish cookie that's got 3 folded sides. And the whole time I was so upset that I couldn't get my folds perfectly symmetric, that in my head I was designing a 3D printed jig so that I could have perfect folding. And that is the type of pastry chef I would have become.
Yeah, that's not my experience. My kind of cooking vocation started as an offshoot of high school when they offered a vocational program to go learn cooking, and to come to find out it was staffed by world-class chefs. And so I got exposed to that. And I always tell people the very first time that I really could eat and make hollandaise sauce, I've been funny but not good looking, but I knew I could get a date with hollandaise, right? So I pursued cooking as a kind of a career and did that for many, many years, and then segued into what they call the point of sale industry, which was halfway between hospitality and restaurants and hotels, and kind of gluing things together, and really started to learn about computers. And there's kind of another long story underneath that. And then I got a lucky break and joined a big corporate company, in 1991. And from there, I'm self-taught. And so I didn't have the comp sci, because the comp sci wasn't really the discipline that everybody pursued back in those days anyway. But I had an opportunity to go through that growth in tech and really get exposed to things and just work really hard at it. I tell people that the same satisfaction of creativity came from programming as it did come from cooking. And for me now, as I get back into it, it's just full circle. It's just that I'm getting ready to kind of step away from the tech industry and then start my own food businesses. And so that's kind of what the circle that I'm on right now.
Well, in this, I like Crowdcast because you get to watch the comments in the social sidebar, and people have been talking about the various solutions they're building. One of the persons talked about, Lori Kay talked about her Natufia Smart Garden, and that's been an interesting product. I think that area in this COVID era we're in, and this idea of food sovereignty and food security. I'm curious, have you, both of you, because you're so interested in the kitchen and making stuff, Are there any things that pop to mind for you in terms of areas of innovation you think are areas for growth, or kind of white spots, white spaces where you think there could be more innovation?
Sure. One that's been on my mind for years, and people are making strides towards, is coffee. I tend to think that anything that involves ritual is a place where this type of innovation can play a role, because you want to refine and refine and refine. So just in the same way that you've seen a bunch of technology help you improve your golf swing, and by the way, I'm not a golfer, because it's these little invisible micro adjustments that help you actually do it right. The same is true of like pulling an espresso shot or doing latte art. You can watch an expert do it and it seems very straightforward, and then you try to do it yourself and things go haywire for reasons that are invisible. But imagine if you had tons of telemetry for every espresso shot you pulled and the way you handled the pitcher when pouring latte art, and you could compare yourself against an expert or compare yourself against yourself, or against your own personal records, through the use of data, through the use of really cheap sensors that can be added to anything. If that was something you were into, what a fun way to improve. Now, I say fun, other people might say that's terribly geeky and want nothing to do with it.
Yeah, one of the experiences I had is I was a private chef for 2.5 years for an industrial farmer. And when I say that, a very wealthy farmer who had 65,000 irrigated acres, right? So he drove around on his farm in a big Mercedes with a cigar packed in his mouth. And he's doesn't kind of fit the model that you think of. But I learned so much about how our food system works, right? And right now, here we are, understanding that we have no self-reliance on our food system, or the local nature of our food systems. Everybody's got a CSA and everything, but it's kind of a novelty thing that we do, or we were lucky enough to be close to it, right? We all kind of know the rural food desert problem, but we're all capable, obviously, of cooking. You see so many people cooking right now, and we're all capable of actually growing something. And so one of the things that I really like is what they call the Garden Tower Project, which is a self-encased, so it looks like a 3D printed model, to be honest, when they first did it. It's got 50 little grow spots in it, and you can grow all your own lettuce and everything. And actually, this thing produces incredibly because of its design. Add some LEDs to it and a few other things, and now all of a sudden you're self-sufficient for the year. And I think also we're going to need to think about water. What does it mean for us to be processing and cleaning our own water? And so all these things kind of bring to mind, this kind of crisis brings to mind the little things that we really take for granted that we hope that the systems are in place for. And the reality of that is that we should probably, I'm not talking about, prepping and building a cavern downstairs, but I am saying there's some things that we should do for ourselves.
I think the COVID problem and what we're experiencing is changing behavior, and I'm excited about what that can mean down the road in terms of design changes and ultimately products that we may see by creative people. We'll be exploring that in some other conversations, so make sure to check some of the other sessions we're doing. We're doing one with Johnny Gray about the future of kitchen design. We do have some more questions real quick. I want to go to this one from Paul Ston. Hopefully I got that right. How do you know the idea is worth pursuing? How do you validate a new idea quickly? I think that's important. Like, should you validate your idea? Is it worth pursuing?
Yeah, I can start there. Yeah, it is really hard to be objective about your own idea. Really, really, really hard. And if you want proof of that, go to any startup pitch competition anywhere in any subject and watch people who are very passionately delivering a pitch for a terrible idea that they don't realize is terrible. And the judges will politely tell them, well, that there's no, whatever, and they just don't see it. And it's part of getting stuck with an idea. And it's very human, it's very natural, and you have to practice to get unstuck from that kind of thing. Now, that said, there are, broadly speaking, two ways to design something or to pursue an idea. The first, or the traditional way, is to go do a bunch of market research and find out what do people want and figure out how well does your idea fit in with what people want. The second way is to make something that you love and then hope and pray that there are other people like you. My personal journey with sous vide very much fell into the latter category. It was that I had come across this thing that a small group of people in forums were experimenting with. I thought it sounded cool. I didn't think, 10 other people would be into it, but I posted a way to get a community engaged and share what I had done, and it turned out a lot of people were. But I didn't pursue Sansaire as a business until there was pretty overwhelming voices indicating that they wanted this thing to exist. And even then, we used Kickstarter as the way to bring it to life, which was a big step for validation. Say, hey, are there enough people here willing to put a little money on the line to prove that there's some value? I would say, though, try as best you can to listen to the signals. If you do a Kickstarter and nobody bites, that's a signal. And you should consider, as hard as it may be, going back to the drawing board, making changes, and really trying to listen to the feedback of people that you trust to improve your idea.
Yeah, the innovator's dilemma, right? This is and you're right about that. I mean, if you're passionate and you love something, the hardest thing is to hold both arguments in your head, and the reality is you're in love with it, right? So my rule is like the latter for you, what Scott said, which is, okay, I'll make one for myself. And then if my friend wants one, okay, great. Now I'm really starting to get some momentum.
Yep. Yeah. In fact, that's my plan for this texture analyzer. Is once I've got it quote unquote finished, my plan is to open source it, and we'll see if anybody else wants one too. And if so, maybe it's a thing. If not, then I'm glad those 4 people were able to make texture analyzers.
It's like being an author. 5 people buy your book. You put a lot of work into it. Who knows?
Right. Yeah. Yeah. But it's hard and it's emotional.
We have another question from Ashutosh. I don't know if I got that right. And they ask, are there any sensors which are safe to put in food and can give data about different parameters, e.g. temperature, viscosity, etc.?
Larry?
Yeah. So when it comes to barbecue and cooking, you're using stainless steel probes if you actually want to start measuring temperature, right? You've got pH meters that you can use for doing things, but actually pH meters in a constant state of monitoring something is actually quite difficult to do because of the calibration requirements and other things like that. And of course, if you've ever made cheese or been around milk production and things like that, listeria and all the other sensors that you want to have so that you can start seeing airborne pathogens and things like that, that is not as sophisticated as it needs to be. If there's an area in the world that I think that we need to make tremendous progress on, it's the ability for us to be able to do sensors that actually do that stuff well. So we're pretty limited, in my opinion, about what we can and can't do right now when it comes to food safety type stuff. But we certainly can monitor humidity and temperature and pH and things like that. But it still feels to me like, I was at a conference this last year and they were talking about, there's a lot of particle type stuff where they can take a look at pollution and smoke density and other things like that. I said, we really need to apply ourselves to being able to take a look at pathogens. What can we do? So that's another area that I'm very interested in.
Lisa McManus from America's Test Kitchen. He says that they have texture analyzers that they used in the test kitchen. That's cool. Yeah. We actually did a poll. I want to state the poll data real quickly because I think it's interesting as part of this conversation. And then we have one more question here. Of the people, not everyone took the poll, but of the people that answered the question, do you have an idea for a new kitchen or cooking product? 8 said definitely yes. So maybe they're ready and raring to get going. 3 have a rough idea, a vague idea what they may be doing or want to do. And then about 13%, about 50% said no, but I might someday. So hopefully we're equipping them with some tools. And I think it's maybe important to say, like, you don't have to have that killer idea that's going to be the next big thing. Building the skills along the way, maybe you'll come up with an idea, right? I would think. Tom from Pantry asks, how important is open source code and hardware to help in figuring out how to build projects? Either of you guys have an idea on that?
Sure. I'll start, and I'm sure, Larry, you've got stuff to say. Larry alluded to this. You can find so much open source code that people have published from their own projects that you can make tremendously useful, complex stuff just from putting together other people's components without really having to do any of the heavy lifting yourself. I mean, all the libraries that power these sensors that do the hard part, you get to just put in one line that says, give me the temperature, please. So open source has made the barrier to entry for doing your own stuff super, super easy. Now, the decision to publish what you've made open source back to the community is a personal one. It depends if you have something that you are trying to monetize and your code is part of the secret sauce, then there is an argument to say that that can't be open until you've made your money from it. But if not, I would encourage everyone who has an inkling to share what you've done so others can learn and benefit from it, as you have almost certainly benefited from other people.
Yeah, I mean, having worked in the corporate environment, and ironically, I work in all open source software in a corporate environment. So, and the reason for that is so that we can see how open source software behaves on our platforms, because that's what our customers are doing. And so this line has been blurred, and it's not even the same conversation that we were having 5 or 6 years ago, in my opinion. So, but the question is that, if you want to give something back and you want people to be able to go do a DIY project, then absolutely go to GitHub, put your stuff out there and do that. If your goal is to make money, then the minute that you engage a trademark or patent attorney, we'll have a different conversation that has nothing to do with software. So, those are just kind of the things. It's like if you've got something that's a good enough idea, and, at Smart Kitchen Summit, you'll see people in both camps. The Ember Cup was an example, right? You want to make a hot cup. It's really cool. You need to get the patents. You need to get the thing locked down. And at some point, you want to make money off that thing. So you're going to want to protect it. And so those are kind of the ways that I look at that. But as far as being able to stitch something together and figure it out, there's just no barriers anymore to that.
It's a democratized world. Well, I just want to say and reiterate that you guys have put together a list of links of resources that you find valuable. Some of the things you both talked about, we have those, and I will send those out via an email from Crowdcast. You can also find them on the Spoon Slack. We click that button down below. We put a file in the Slack. It's our open Slack, anyone can join. But before we go, where can people find you guys if they want to get a hold of you? Scott, I think you have a website.
SeattleFoodGeek.com, or that as the handle for all the social platforms. Feel free to reach out. I'll do my best to reply.
Larry?
Yeah, and I've got salumi.cloud, which is the place where I do all my kind of making of my Saluminator and all that stuff. And then my email, which is, I don't know, does that get published out of this, Scott?
We can see, we'll put it in the email. We'll put it, I wouldn't put it on the video, but I'll send it out to people. We can do it that way. Yeah. So
I'm easily found on LinkedIn too.
Yeah,
so.
Find it on LinkedIn. This has been great. I appreciate it. Thanks, guys, for doing this. And if you guys have any follow-up questions, I'm sure you can just reach out to either Scott or Larry. Thanks once again for joining us, and we'll see you guys later. Have a great one. Bye, everyone.
Awesome.
Bye.